Let's graph the y-coordinate going around the unit circle in the same way. We're going to follow these same steps with one change. We're going to plot the 1, 0, negative 1, 0, 1, 0, negative 1, 0 to get the general shape, the up and down shape. Then we're going to locate the 1/2s, where when we were graphing the x coordinate around the unit circle, we get x equals 1/2 at 60-degree reference angles. Now that we're graphing y is equal to 1/2 at the 30-degree reference angles. So that's what we're going to mark as the 1/2s at the 30-degree reference angles. Then we're going to do the same thing. We're going to connect the 1/2 and the negative 1/2 with just a line and make the graph flat at the top and the bottom, and then connect the bendy parts, starting flat at the top and the bottom, and then hitting the little line segment parts with the same location and direction. So we're trying to aim for the same location and direction. So here we have the graph set up. Once again, I've marked off each quadrant in thirds. So here's quadrant 1 from 0 to 90. Here's quadrant 2. I forgot how to make a Q for a second there. From 90 to 180 in quadrant 3. From 180 to 270 in quadrant 4. From 270 to 360. Now I've only labeled the 30-degree reference angles. That's where we're going to find our 1/2. And I left off the 60s to kind of write less stuff on my theta. But let's first figure out what's happening at each of the quadrant angles. Let's plot the 1, 0, negative 1, 0, 1, 0, negative 1, 0. The y-coordinates on our unit circle, the y-coordinates is 0 at 0 degrees, 1 at 90, 0 at 180, negative 1 at 270, back to 0 at 360. So the y-coordinate starts off at 0, then goes up to 1, back down to 0, down to negative 1, and then back up to 0. So we've got this up, and then down, and then up. That's the first step. Locate your 1, 0, your 1s, 0s, negative 1s, and 0s, and 1s, 0s, and negative 1s, and 0s. We're graphing y-coordinates. The other point that's easy to find is y is 1/2 at the 30-degree reference angles. So at each of the 30-degree reference angles, I'm going to mark y 1/2, and it's going to be the one, whichever one works. So when theta is 30, y is positive 1/2. And then when theta is 150, y is positive 1/2. And that keeps us going with flows with the up and then the down, and then it goes down at 210. We'll be at negative 1/2, down, then back up, negative 1/2 at 330. So there are our 30-degree reference angles, where y is 1/2. Now we're going to do the same thing we did before. We're going to connect the 1/2s with just a line. Graph is not technically linear, but it's pretty close to being linear. So I'm just going to connect those with lines. And I'm going to make the graph flat at the top and flat at the bottom. Next, I'm going to connect the flat parts to the line segment parts. I'm going to connect the top and bottom to the 1/2s, making sure that it's flat at the top and the bottom, and hits the 1/2s going the same location and the same direction. So we're going to be flat at the top, and then same location and direction. Flat at the top, and then just kind of bend this down. Flat at the top, same location and direction. Flat at the top, same location and direction at the 1/2. Since we're just sketching anyway, we don't have to be perfectly precise where our square root of 3/2 is. So it's easier to just draw the bend like it's supposed to look rather than try to locate the point root 3/2 on the graph paper. Especially when the graph paper has resolution only out to like 1/4. So easier to make the graph look right, and then retroactively go and find here's 60 and trace that up. To root 3/2, which is about 0.8660. Any questions? So far as estimation goes, here's the 1/2. So each of these is a 1/4. So halfway between a 1/2 and a 1 is a 3/4. And 3/4 is a 0.75. And then the 1 is at a 1. So the 0.8660 should be close to the 0.75. That's only 11 off over the 0.75, and then the rest of it up to the 1. That leaves 11 going above, and then 14 below. So it makes sense that it's, so we got a pretty good bend here. Any questions? Yes. Correct. Approximately. So the main reason I like doing it this way is that we're pretty good at estimating if we're drawing pictures. We're pretty good at visually drawing an estimation. We're really bad at doing it with numbers. We are really bad at estimating with numbers. Them is just fact. We are bad at estimation when we're dealing with numbers. Any questions? Everybody's like all mad at me. They'll be mad at me. Make fun of my ability to estimate with numbers. I'm not making fun of you. I'm making fun of everybody. We're all bad. Okay. Same as before, we can continue this following this pattern. So in 30 degrees, we'll be at the next 1/2. But then to get to 1, we'll take 60 degrees. And then same location and direction, flat at the top. To get back down to 1/2, we'll take 60 degrees. But then only 30 degrees to get down to 0. And then 30 degrees to get to negative 1/2. So here's what where the next line segment would look like. We connect flat, make it flat at the top. And same location and direction for the line parts. You can even put the 30 degrees and the -1/2 here, but it kind of runs into where I've labeled -1/2. Now you might look at this graph with the y and think this looks like the graph that we had with the x, just kind of like shifted over 90 degrees. The reason that looks like that is because it's exactly that. It's just been shifted. This is just take the previous one and shift it over 90 degrees. How's everybody okay? We're trying to learn the unit circle. We're building a map for the unit circle. We're drawing it out by hand in excruciating detail because it'll help us see the patterns, and the patterns will help us remember the values. So I have to be able to say things. What is the sine of 210? And have you know right away that it's -1/2. And the first thing that's going to happen when I ask for the sine of 210, you can imagine this. There's the 210, there's the -1/2. Or the sine of 210, here's the 210. There's the -1/2, because the sign you're going to associate with the y coordinate. When I ask about x coordinates, you're going to be thinking of the cosine, or if I ask about cosines, you're going to be thinking about the x coordinates, either in this graph or the x coordinates going around the unit circle. And so I have to be able to say, what is the cosine of 300? And you have to immediately know that it's 1/2. Either because you're thinking about this point at the 300, and there's the 1/2, or you're thinking about this point on the graph, there's the 1/2. Or you're breaking it down into pieces. You're saying 300 has a 60-degree reference angle, cosine of 60 is 1/2, and we're in the fourth quadrant, so it's positive. One of those ways will get you to cosine of 300 is 1/2. The utility of that is questionable, but at some point you had to learn that 7 times 8 was 50 something. 56. At some point you had to learn your times table so that when the teacher's like, oh, 7 times 8, you're like, 56. And you didn't have to think about it, you just knew it. Because later on we're gonna have to turn that shit around. And they're like, all right, now it's 56 divided by 8. You're like, 7. And it's like a programmed reaction. You don't know where that came from. It just came from programming when you were a child. I mean, teaching you when you were young. Is that okay? The unfortunate thing is like, oh, right now we're like it's like a room full of like 18 to 24-year-olds. And you'd pick this up much faster if you were like 7-year-olds. Take out like the concepts and shit, but just like program you with this information when you're 7, and you're like, I don't know where that came from. The trouble is we try to teach trigonometry to like surly teenagers. So, screw you, old man. I'm not gonna listen to your shit. You know what I mean? How's everybody okay? Everybody looks so sad. All right, so your job is to learn the unit circle, 30, 45, and 60-degree reference angles in all 4 quadrants, the quadrant angles, and the coordinates. So I want this picture in your mind. I want to be able to hand you a blank circle and have you fill it out. The speed at which you want to be able to do this. If I hand you a circle with all this stuff marked on it already, and you just had to fill it out, the way it would work is if I had a piece of paper, I would hand out the piece of paper, you pass it down this row, I'd hand out the papers. And then when I got to that side of the room, I would just walk back to this side of the room and I would be collecting them. That's where you want to be. Now you're not going to be that way, that place today. Right? You're still going to be thinking about it. But that's the goal. I want to be able to hand out, have this as a quiz. I don't know if I'm not actually going to do this. It's just too stressful if you know that I'm like walking back. If you're like trying to do stuff, like write stuff down and do math and remember shit, it's not okay for me to like be putting pressure on you, like I'm walking towards you and you're trying to fucking concentrate on it. You know what I mean? Like how much worse is that? You can't get your work done. Like if you're trying to do a problem, and I'm like standing here. See how uncomfortable it makes you? So I can't be like handing out papers, and then like you're over there because you're aware of the fact that you're back to the side of the room. And I'm like, oh shit, I'm only got like 10 seconds to go. And here I come. So it's just like it's just really weird. You know what I mean? Math tests are shitty. I don't really have a good answer for finding out information that I want to find out, but I know math tests are just bad. Part of the reason that math tests are so bad is because we start giving you tests when you're too young to do tests. We start giving like 6-year-old tests. And we're like, well, why are these kids so traumatized by these tests? It's like, well, because you started giving them tests when they were 6 years old, you dumb motherfucker. What do you think was going to happen? And then you told them, it's like, oh, this is really important. If you do bad on this, you're bad. And then they get mad at you for doing bad on the tests. It's like, oh, no shit, that's going to happen. It's a 6-year-old. Have some fucking humanity. Anyway, when I'm in charge of the world, you don't get to even assign kids homework. No, there's no homework. None of that shit. You're children. You learn to treat each other nicely. And maybe your times tables. And if you don't get the times tables this year, that's okay. Next year we'll do the same thing. Just reinforce it then. You get to start doing homework when you're a junior in high school. That's when you get to start doing homework. And when you're a junior in high school, you can start taking practice tests. Maybe we'll like sophomore year, you can start doing homework. Junior year, you can start doing practice tests. But it's like there's like a whole build up to it. It's like, well, this is what the test's going to look like. And this is what it's going to sound like. It's going to be really quiet, which means listening to the fluorescent lights. It's really weird. But you practice it when you're like almost adults, like the juniors in high school, right? Then when you're a senior, the test can actually count after a couple of practice ones. You know what I mean? And the SAT is just banned. There's just that doesn't exist anymore. Anybody taking the SAT? You know what the SAT tests? It tests how good you are at taking the SAT. That's it. How good are you at taking standardized tests? That's what it's making. And I'm not saying this because I'm bad at those tests. I shit you not, I'm very good at those tests. This is one of the stupidest skills I have. I would trade this skill for almost any other skill, but I'm really good at standardized tests. Multiple choice, that means one of these is the answer, and you think I'm going to study. You're handing me the answer. You're hiding it in a bunch of bullshit, but you're handing me the answer. You know what I mean? So that is one of my most useless skills. I'm really good at written tests. Anyway, I want you to have the picture of this unit circle. I want you to associate the x with the cosine, and I want you to associate y with the sine. I want you to see these flowy graphs, these up and down graphs, these waves as just going around the circle. I want you to imagine going around the circle and creating these waves as we go around. We did this by hand because that's the point. The point is the creation, so that we notice when the halves happen. That will help reinforce remembering our sines and cosines of our common angles. How's everybody, okay? All right. You have until Wednesday, and if you don't, you're going to be a failure for the rest of your life. I'm just trying to bring that extra nostalgia for when you took the test when you were here. I'm not really serious. You'll be fine. You'll be fine. That's it for today. I'll see you all on Wednesday. Everybody have a good couple of days, and thanks for playing.